the last video, the question was f of xy equal to x square minus xy plus y square by 2 plus 3 at point 32. The question was find the upper bound for the error. First to find L of xy. We have already found that. Find an upper bound for the error in the approximation f of x is approximated to L of xy. Over the rectangle r equal to mod x minus 3 is less than or equal to 0.1. Mod y minus 2 is less than or equal to 0.1. Express the upper bound as the percentage of f of 3 to the value of f at center of the rectangle. So the solution is, this is error. E of xy equal to less than or equal to 1 by 2 m into mod x minus x naught plus mod y minus y naught whole square. So we have to m is the upper bound for mod fxx, mod fyy, mod fxy. Here fx equal to 2x minus y at the point 3, 2. We can see that this is equal to 4 and fxx is equal to derivative of this with respect to x, that is 2. Fy is minus x plus y. At the point 3, 2, the value is minus 1. And fyy means derivative this with respect to y, then 1. Fxy is differentiate this with respect to, differentiate fy with respect to x. So that is minus 1. So what will be the mod fxx, which is equal to mod fxx is 2. Mod fyy equal to 1. Mod fxy equal to 1. So m will be 2 here, which is a upper bound. Choose m to be 2. So mod e of xy is less than or equal to 1 by 2 into 2 into mod x minus this is 3 plus mod y minus 2 whole square. This is equal to mod x minus 3 plus mod y minus 2 whole square. And finally we have mod x minus 3 is less than or equal to 0.1 and mod y minus 2 is less than or equal to 0.1. Therefore, mod e of xy less than or equal to 0.1 plus 0.1 whole square. We apply here. Is equal to 0.2 whole square, which is equal to 0.04. And one more, the percentage of error of f of xy at the point 3, 2. So this is percentage of error is equal to 0.04. This is the error divided by f of 3, 2 into 100. This will become 0.04 divided by 8 into 100. This will become 0.5%. This is the answer. So f of xy, from this question we can understand that f of xy is approximated to L of xy. Be error not more than 0.04. We can approximate this f of xy by using the L of xy by not more than 0.04. Not more than 0.04. Right, this is the answer. Next is some definition. The total differential absolute, relative, relative and percentage change and percentage change. These are we are going to define. Okay. So predicating change with differentials in this the total differential is defined as total differential of a function f is defined as df. This can be total differential means there is a change from a point to another point. There is a change in function f when we move from the point when it moved from the point x0 y0 to another point. That is df. That is, if we move from y0 to another point x0 plus dx y0 plus dy, the resulting differential, that is change in f, is defined as fx at the point x0 y0 into dx plus fy at the point x0 y0 into dy. This is a change in the function f, and this change in the linearization of f is called the total differential of. This is termed as the total differential of f. This is termed as the total differential of f. Is it clear? So df is the total differential and is defined as fx at the point x0 y0 into dx plus fy at the point x0 y0 into dy. This is a formula. You have to note it carefully. Next question. This is a question. Your company manufactures right circular cylindrical molasses storage tanks. Right circular cylindrical molasses storage tanks that are 25 feet height with radius of 5 feet. How sensitive are the tank's volume to small variations in height and radius? This is a right circular cylindrical. Circular cylindrical tanks means this is the type. So for the cylinder we have how sensitive are the tank's volume to small variations in height and radius. First we have to find out the volume for that. So what will be the volume of this cylindrical shape? We know that's equal to pi r square h. What will be the how sensitive are the tank's volume to small variation? That means we have to calculate the change in volume corresponding to change in height and change in radius. Here this is a volume equal to pi r square h. This volume depends on the two variables radius and height. So the change in volume happens when change in radius and change in height happens. So the change in volume is equal to dV. dV equal to the derivative, that is by using the definition I have this is fx into dx plus fy into dy at the point x0 y0. Here this is fx means we are at the point r, h means r is 5, h is 25 into dr plus vh at the point 525 into dh. What is vr? Means derivative of this with respect to r. That's equal to 2 pi r h at the point 525 into dr plus what will be vh, that is pi r square at the point 525 into dh. This is equal to what? This is equal to 2 pi r h, that's equal to 1250 pi dr plus 25 pi dh. Okay, so 250 pi dr, 25 pi dh. Suppose dh equal to suppose dr equal to 1 unit. Then this change happens by using this radius is equal to 1 unit change in r will change v about 250 pi units. 250 pi plus something. So it will change v by 250 units. So if dh equal to 1, if dr equal to 1, dv will be 250 pi plus something. And if dh equal to 1, dv will be 25 pi plus something. Okay, so 1 unit change in height will change v by about 25 units, and 1 unit change in r will change v by about 250 pi u. So the tank's volume is, this is 225 pi into 10 is this change. So more sensitive in this case. Tank's volume changes in this case. This is a more sensitive. So the tank's volume is 10 times. Tank's volume is 10 times more sensitive to a small change in r than small change of equal size in h. Tank's volume is 10 times more sensitive to small changes. That is, suppose dr equal to 1, dh equal to 1. What will happen? dv 250 pi plus 25 pi. That means this when dr equal to 1, this will become 250 pi plus something. This will become 225 pi plus something. So the change is more in this case. That is, if the same changes applied to the radius and height, then Planck's volume is 10 times more sensitive to small r rather than this small change of equal size in h. Okay. So next we are going to define the absolute, relative, and percentage change. We have the absolute change, the true change, and estimate change. The true change means that is a delta f, and estimate change is df. Relative change is equal to delta f by f of x naught y naught. This is df by f of x naught y naught. Percentage change means delta f by f of x naught y naught into 100. This is df by f of x naught y naught into 100. This is you have to study well. You have to study, right? Absolute change, relative change, percentage change. We have been need. This is we need.